Hi everyone, welcome to our channel. Today we will be discussing partition pruning. Partition pruning is a powerful optimization technique in PySpark that significantly enhances query performance by selectively reading and processing only the necessary partition of data. In this tutorial, we will explore the concept of a partition pruning, its functionality, and how it can leverage to boost the efficiency of your Spark application. Okay, here we go. First, import import necessary libraries. Import PySpark.sql Spark session and create a Spark session. Spark equal Spark session dot builder dot app name partition pruning. Okay, and get or create create a data frame with the partition data. Okay, we start by initializing a Spark session and creating a data frame df with the partition data based on the value column. Okay, we have a data frame with the two columns, ID and value, and partitions data based on the value column. Okay, next step, partition pruning with a filter. I want to define a filter condition for partition pruning. Filter condition equal value equal a okay, and apply the partition pruning pattern. Result with partition pruning df dot filter condition. Okay. We define a filter condition value here. Okay. Value equal a that can benefit from the partition pruning. The filter operation here operation is applied to data frame, and Spark optimizes the execution plans by only access partition relevant to filter condition. And next step is display result and execution plan with the partition pruning. Print result with the partition pruning. Okay, and next line, result with the partition pruning. Okay, that show and display the execution plan with the partition pruning. Print execution plan with partition pruning. Okay, sorry. And that explain okay. We showcase the result of a query with the partition pruning applied. Additionally, we print and explain. I want to explain the execution plan, emphasizing the efficiency gained through partition pruning. Okay, and another example: filtering without partition pruning. Result without partition pruning. Okay, and df dot filter filter. Okay. Okay, repeat the filtering operation without explicitly leverage partition pruning. Okay, and here print result plan without partition pruning. Okay. And here, okay, that show and display the execution plan without partition pruning. Print execution plan without partition pruning. And result without partition pruning and explain. Okay, we showcase the result of the query, and the execution plan is printed, print and explain to the contrast with the partition pruning. Okay. I will compare two execution plan. Okay, here, okay, you can see it, execution plan for partition pruning and without partition pruning. In the execution plan with partition pruning, here, the plan is adapted dynamically during execution, and the exchange operation. Operations involved by only necessary partition, leading to more efficient query processing. And without partition pruning, the same exchange filter operation occur, but all partitions are scanned, potentially resulting in less efficient use of resources. Partition pruning is crucial for optimizing query performance, especially when dealing with a large dataset and partition data. Thank you for watching.